Gold is a highly sought after precious metal. It's become one of the world's most well-known metals. People all across the world are aware of and appreciate its high worth and yellow shine. Today we'll take a look at the intriguing science underlying gold and where it comes from. Before we get further, be sure to subscribe to the channel and ring the bell to get notified about our latest videos. Alright, let's get going. First up, what makes gold so valuable? The first reason behind the value of gold is its rarity of this precious metal. Its value was proportionately higher since it was more scarce than silver or copper, two other metals mined since antiquity. Second, gold possesses extraordinary powers. It doesn't tarnish, it's very easy to work, it can be drawn into wire and hammered into thin sheets. It alloys with many other metals, and it can be melted and cast into highly intricate designs. It has a beautiful color and spectacular luster. Since ancient times, all of these properties have been attainable by melting gold nuggets at high temperatures and employing basic tools like hammers or molds. Because gold is so spectacular, it's no surprise that its principle of application is in jewelry. Since time immemorial, the noble metal's brilliant sheen has allowed it to be created into the world's most prized and magnificent jewelry, appropriate for queens or kings. The majority of newly mined or recycled gold is now utilized to make jewelry, and every year around 78% of the gold that is available rather than stored is used for this purpose. Because of its high value and scarcity, gold has long been used as a medium of exchange or money. Around 6,000 years ago, gold was used in transactions for the first time. Initially, gold or silver coins were used in transactions. Because of the function, scarcity, and attraction, gold has long-term value. Around 560 BC, King Croesus of Lydia ordered the first gold coins to be produced. Up until the early 1900s, gold coins were extensively utilized in transactions when paper currency became a more common means of exchange. The United States once employed a gold standard. Anyone could present paper currency to the government and demand an equal value of gold in exchange. Perhaps gold's most useful feature to mankind did not appear until the early 20th century, when its incredible electrical conductivity capabilities were discovered. Solid-state electrical devices operate at extremely low voltages and currents that are easily disrupted by corrosion or tarnish at the contact points. Gold is a highly efficient conductor that can transmit these tiny currents while being corrosion-free, which is why gold-based electronics are so reliable. Almost every advanced electrical equipment has a trace of gold. Cell phones, calculators, personal digital assistants, global positioning system units, and other compact electronic gadgets fall into this category. Where did gold come from? Like most heavy metals, gold is created inside stars via a process known as nuclear fusion. Following the Big Bang, just two elements were created, hydrogen and helium. The earliest stars were blazing with nuclear flames a few hundred million years after the Big Bang. The nuclear processes produced a large amount of energy by combining lighter materials to form somewhat heavier components. These early stars gradually began to produce elements such as carbon, nitrogen, and oxygen, progressing up the periodic table toward iron. However, there was no gold in the universe. When these earlier stars ran out of light elements to burn, they turned their attention to the heavier ones. They erupted as a supernova when they burned silicon to form iron. For a few brief moments, each star released as much energy as all the ordinary stars in the galaxy combined. For the first time, atoms of gold were created in that cataclysmic explosion, and then blasted out into the universe with the rest of the debris. Gold arrived on Earth around 200 million years after the planet's formation, when meteorites containing gold and other metals pounded its surface. Molten iron sank to Earth's core during its formation to form the core. This destroyed the great bulk of the world's valuable metals, including gold and platinum. The core contains enough valuable metals to cover the entire Earth with a 4-meter thick covering. Another popular theory regarding the production of gold is that metal can emerge as a result of the collision of two neutron stars. What remains after the explosion of a huge star, at least 8 times more massive than the Sun, is an extraordinarily dense core. They have a massive equivalent to stars, but mass that is compacted into 10-kilometer diameter object, around the size of a city on Earth. Another way to look at it is to imagine packing Mount Everest into your morning cup of coffee to obtain the same density as a neutron star. Exotic physics stretches the fabric, space, and time at such high densities. When gravitational waves convey enough energy away from the system to disrupt the orbit of two neutron stars in mutual orbit, they can collide. When this happens, a gamma ray burst can occur, which is the most powerful explosion in the cosmos. The tremendous energy would be sufficient to generate gold and other heavy metals. Well guys, that's it for this one. What'd you think about it? Let us know in the comments below. If you're new to our channel, be sure to subscribe and ring that bell to get notified about our latest videos. Thanks for watching, and we'll see you next time. Bye-bye.